Well, if you have done any solving of equations in the past, let's take a look and see how well you know them. So if you're somewhere around grade 9, say maybe even grade 8, okay, depending how much math you have done, or grade 10, you should be able to solve these questions. So I've created this little mini test which has only 6 questions, and I will do the link to the actual test so you can download it in the show notes below. You can hit on the show notes, there'll be a link there. And if you are struggling with anything in terms of trying to solve equations, I will also post a link above that will help you, okay? It is basically kind of a playlist that you can watch numerous videos on how to go about solving equations, from simple ones to harder ones. The ones that you see in this particular test are not that easy. They're not easy for purpose because I'm actually curious to see if you can do them. So you can leave comments, you can try this particular test and see how good are you, all right, in terms of your material in solving equations. So I will solve them, so don't look at the solutions until you actually try yourself to try to see how well you know this stuff. All right, let's begin. Okay, so question number 1. So I'm gonna blow this up a little bit. Okay, so we're gonna work through this. All right, so we have this question. So luckily, so no decimals, no fractions. So there's basically a bracket on the left and a bracket on the right. So I always like to just get rid of the brackets and distribute through as much as possible so that I have no brackets at all. So I'm gonna distribute this inside of here. So 7 times 8. So we have 56 minus 7m, and then we have minus 3m here. Next, I will distribute this, okay, so across here. So that's going to be 6m minus 12. So now that there are no brackets in here, now I'm going to basically collect like terms. So what I like to do is I like to bring in all the terms with my variable. So that are these ones on one side. Typically I'll pick the left side, not always, and then I'll bring everything else on the opposite side. So let me do that next. So that's going to leave me negative 7m minus 3m and minus 6m. So because I'm bringing the 6m over, so the sign changes. And then on the opposite side I have negative 12, and then the 56 will change to negative 56. So that's the second step. So now in terms of the collection, obviously I can collect like terms right here, and I can clearly just take these two numbers and combine them into one. So I have now, so 7, 3, 6, notice they're all negative. Okay, so this is going to be negative 16m is equal to, now negative 12 and negative 56. So that will be, what, 66, 68, so negative 68. So that's next. Now isolating for m, all right, so now we're gonna get rid of this factor in front of the m, so we can divide both sides by negative 16. So this you don't have to really show per se. So that's going to cancel this off, and it's going to give me my solution, which is 68 over 16. It says leave the answer as fraction if needed, so we can just stop here. The goal is ultimately, can you solve the equation? Now we can reduce this, of course, right? So you can reduce this 68 over 16. I'll leave that for you, okay? But in terms of solution, you are finished. So that is question 1, okay? Question number 2. So let's scroll down here. This one is a little bit more annoying probably because we have fractions here. All right, so in terms of fractions, so let's take a look. So again, just because you have fractions, it doesn't change anything for us in terms of the process. So I will distribute across. So we're going to bring this inside. So that's going to be negative 2 over 3 x, because we're multiplying, and then we have plus. Notice the 2 over 3 multiplied by a half, so that is going to be 1/3, and the reason is because when you're multiplying this out, so notice this 2 and this 2 will cancel, so you have 1/3. On the right hand side, we have x over 4 minus 2 over 9. So I got rid of the brackets, so that is finished. Now I'm going to collect my like terms, so I'm going to take my terms with the variable, put them on one side, and put everything else on the opposite side. So if I do that, I will keep this right here. That x over 4 is going to switch over, so it's going to be negative x over 4 right here. Then we have negative 2 over 9 minus 1 over 3, so that one switched over for us. So this I'm bringing over to this side, and this I'm brought over to this side. Now, yes, it is fractions, okay? So again, so it says leave as fractions, so I'm just going to work with the fractions, okay? So as we have, so I can go ahead and try this. So I need a common denominator between these two, so 3 and 4. So common denominator is 12. So I'm going to put these over 12. All right. Now, if I do that, this is going to become negative 8x. And if I do that here, so negative 12, that's going to become 3x. And this is why you need to know your fractions, right? And finding common denominators, because they chase you around. So that's on the left-hand side. On the right-hand side, I need a common denominator between these two. That's a little bit easier because I see that the 3 goes into the 9 3 times. So 9 is going to be my common denominator, and this is going to be negative 3 over 9. All right, so I just changed this, multiplied it by 3, so I have to do the same thing to the numerator. And now it's basically just working through, so bringing things together. So I have negative 8 minus 3, which is negative 11 over 12x, so that's on top there. Now on the right hand side, I have negative 2 minus 3, so that's going to be negative, and this is 5 over 9. Now, one thing, if you do notice, this happened also in the previous question. If you have a negative and a negative, okay, those negatives will cancel, okay, because you have them on both sides, so you can technically drop them, all right? So those negatives will cancel each other off, because it's like dividing by -1 on both sides. And now, so in terms of trying to solve this, so notice what happens here. So here I'm going to multiply this side so that 12 over 11 cancels, and I will do the same thing on this side, 12 over 11, and that's going to give me x equals. And now I can check, can I reduce this a little bit? I mean, you can go ahead and say 5 times 12 and 9 times 11, but I do see actually 9 and the 12, so 3 goes into both, right? So I can divide the 9 by 3 and the 12 by 3, so that's going to be actually 4, and this is going to be 3. I can't really reduce anything else. The 5 is a prime number, and so is the 11. So now this is pretty much it. So 5 times 4 is 20, divided by 3 times 11 is 33. And I will leave it as a fraction because that's what it said to do. So that is question number 2. I wonder if you got it. Let's move over. Question number 3. Let's see what this one has in store for us. So here it says solve for unknown and leave answer as a decimal, round to 3 significant figures. So this will kind of bug you about significant figures. If you want to learn about significant figures, I'm going to put a link up on top if you really want to know how to count significant figures. So I'll do that there so that you'll see what I have done at the end in terms of solving this. So let's get started. Okay, so now I'm going to blow this up again. And now in terms of working with this, so I will get rid of all these brackets by distributing. So I'm going to distribute this negative across. So I have 1.2y minus 1.5y minus 10.5. So that distributes across. I have this 3.5. So I'm going to bring this now and distribute it across. So I have 3.5 times 1.1. So we can cheat a little bit. Okay. So I'm going to take this out in here and say, so 3.5 times 1.1, okay, just in case, so 3.85y minus, now I have to take the 3.5, so 3.5, and it's times 8.2, so 28.7, so that distributed across through there. And now no more brackets, so now again, notice it's the same thing. I am going to collect like terms, so bring in this case, what I'm bringing in is I'm going to take all my terms with the y, bring them to one side, so I'll do that. Let me maybe switch the color. So I have 1.2y minus 1.5y. I'm going to bring this over to the other side, so that's going to be negative 3.85y. And on this right-hand side, we have negative 28.7. And I'm going to bring this over to this side, so plus 10.5. And now go ahead, so we can work with these. They are decimals, so I'll save myself a little bit of time by grabbing the calculator. So 1.2 minus 1.5 and minus 3.85. And that's going to be negative 4.15y equals, and here, what did we have? So let me switch this over, and I have negative, so negative 28.7 plus 10.5, which is negative 18.2. All right, so let me remove that. And now again, so I have negative and negative on both sides, so that will cancel. I will now divide both sides by 4.15. So I mean in full. So if you like, so I'll write it in. So what you're going to do is the following. So as I said, these two negatives will just cancel off. And now we have, let me take out this. So we have 18.2 divided by 4.15. And that's going to equal to 4.38554 and so on. Now it's said to round to 3 significant figures. Well, 3 significant figures, so if they want to just keep 3, so I'm going to round and keep here 3. So that's 4.39. Okay. And that would be the answer to number 3. Again, if you want to watch those significant figures, go back to that link that I had when I was starting this question. Question number 4. Let's see that one. Let's see if you can handle this. Now, all of a sudden, we have brackets. We have our variable at the denominator. So notice right here, a little annoying. So what do? Well, we cannot have, okay, our variables in the denominator if we're solving for them. So what I will do is I will get rid of the denominator by multiplying both sides by 3x minus 5. So basically, I am dividing here, right here, by 3x minus 5. So I will multiply, and this will get rid of the denominator, but I have to do that also to the other side. So that's that. Now, once I do this, let me clean this up a little bit for you so you will see what is happening. Minus, so 4 plus x is equal to 7. So it is a long one now, but no more denominator. Everything is nice and clean. I have brackets, so I'll start getting rid of these brackets, okay, by distributing across. So 4x minus 16. Now distribute the negative. So negative 4 minus x equals, distribute the 7. So that is now 21x minus 35. Brackets gone. So now let's collect all my like terms. So terms with the x, I have these. So let me bring them to one side. So that's 4x minus x minus 21x equals negative 35 stays on its side, and then it's going to be plus 16 and plus 4. So that's what we have here. Now I can add and subtract everything that's needed. And we have, so negative, so that's these two right here. So those are both negative, and then a positive. So that's going to give us negative 18 in total. So 4 minus 1 is 3. 3 minus 21 is negative 18. On the right-hand side, we have, well, this is 16 plus 4. So that is actually 20. And when you're going to be adding into that negative, you're going to see this is negative 15. Now divide both sides, so by negative 18, and you are done. Again, these two negatives just cancel, and we have, so 15, whoops, we have 15 over 18. This one is much easier to try to reduce. You don't have to. It says to leave it as fraction, so you can leave it there. If you wanted to reduce, you can divide both by 3, and you get 5 over 6. That was question number 4. I wonder if you got it. Question number 5. Let's see what this one entails. It's shorter. It has, in the denominator, on both left-hand side and right-hand side, a variable. So hopefully you can kind of tell that we can alternate these, get rid of them. So what I can do is I can literally multiply this side, okay, by that, which means that it's going to be multiplying this by that. So that will cancel off. All right. Let me do that just so that you can see what happens. So this is now negative, and negative is actually positive. So I'm going to do that right away so that I just have a 4 there. So this is 4 equals, now here we have 3 and negative 1 over x. Now I still have, okay, this x at the bottom. But I'm going to do exactly the same thing. So I'm going to get rid of this by multiplying both sides by x. So that means this x will cancel, and x times the 4 is 4x equals 3 negative 1 minus x. That's that. You don't always have to show that you're multiplying on both sides. Typically, people will just cross it over on the opposite side. And now, once you have done this, let me get rid of these brackets by distribution, and it will make our question a lot simpler. That's just that. Bring in your like terms to one side. So we're going to get 4x plus 3x equals negative 3. This is 7x. Okay. And we are done. We can now divide both sides by 7, which is going to give us that. And that's as good as it comes for this one. So that was question number 5. I wonder if you got that one. Question number 6. So for question number 6, so it looks nice and simple here. It's not super complicated. There's no fractions or decimals or anything. There's quite a few brackets. So let's simplify these. So if I blow this up a little bit, we have, so I'm going to distribute this across. I have 2h minus 20. I'll distribute this across. I will have 3h minus 36. And I will now take this. I can distribute this across, but notice, before I do that, I have a negative and a negative. So this right here is basically, so 5, h plus 1 plus 3. That's what that equals on the right-hand side. So if I'm distributing across, I will get 5h plus 5, and then that remaining 3 right there. Now let's group all of them together. So that's going to be 1, 2, and 3. So 2h plus 3h, let's bring this over, minus 5h equals 5 plus 3. Now I'm going to bring that negative 20 over. It's going to turn positive. And bring this over, and again it's positive. Now this, we get 0h equals, and now we can add these up. So that's going to be 5 plus 3 is 8. All right, the 20, the 36. So that's what, 56 plus 8. 56 plus 8 is 64. Now we have a problem because we have 0h. And I wonder, because there's two cases always. So for example, you can have, if this ever happens, or right now, as it just has happened, okay, if you have some number n. So if you have a variable right here, okay, and you have zeros on both sides, if this happened, here we basically would have as our answer any number we like. Because whatever you substitute for h, let's say if it's 5, okay, minus 100, 2/3, whatever, and you multiply it by 0, you always get 0, right? So this is what we have here. This always equals to 0. And what this is saying, 0 equals to 64 on this side, which can never happen. So this has no solution. All right? And if, on the other side, if we had this, which would say 0 equals to 0, okay, this has infinite number of solutions. Meaning you can pick any number you like and it will always work. So I hope that through these examples, you know, you can test yourself, and I wonder if you were able to do it under the 30 minutes, right? You can leave a comment if you have questions. You can leave some comments there as well. You know, test yourself, you know, especially if you're a grade 9er. Okay, so all the 9ers, make sure you know how to do this before you go on. It will help you quite a bit in terms of knowing how to solve equations. All right, thank you for watching, everybody. Okay, take care. Peace. Bye.